Okay. Class has begun. Let's do this thing. Yeah. Is everybody ready?
No.
I'm still a little
Okay.
bit shook.
Quadratic equations. So
Literally going to fall over. What page? Sorry.
this is page 249. Okay. So little review. A polynomial is anything that takes the form of ax to the n plus, and then like ax to the n minus 1 plus ax to the n minus 2, so on and so forth.
Huh?
This is just polynomials. This is just a review of what polynomials are. They are expressions like this of decreasing degree, where x has coefficients and stuff like that. Make sense?
Yeah.
And everything in between the plus or minus signs is a term. So these are terms. And the whole thing is a polynomial. Okay, when we talk about polynomials, quadratics are in there. We classify them by degree. And this is something you should have done in Algebra 1. So if you have x to the third, what's the degree?
Third.
3! Yes!
Oh, okay.
The degree is the 3. If you have x to the fifth plus 2x squared minus 16, what's the degree?
Would it be 5 plus 2?
5. It's just a 5. Because if they're
it's the one
separate
that's the
terms, then you don't add them together. You just go with the highest. But if you had this, what's the degree?
15.
8. Because you add these together if they're
I
a
thought it
single
was
term.
5 times 3 because there's times.
Oh, no, I just add it.
Oh, okay.
Okay,
Wait,
so
what was that one be? Sorry.
if this is
So you
8,
add them.
right,
But it's the next.
so it has a degree of 8. Okay, so degree just means the highest exponent in a polynomial. But if your terms have more than one variable in them, you add the exponents together to get the degree. Does this make sense? Cool. Okay. Quadratics are polynomials with degree of 2. And that's really all they are. Barrel! So, quadratics. Does not have anything to do with the number 4, even though it starts with quad. It's called quadratics because what does a quad look like? If you're out in the quad in school, what does the quad look like? Does anybody know what a quad is? Like, hey, have you seen... I can only think of Samantha and Isabel's name. I'm trying to... Betsy. Have you seen Betsy? Yeah, she's out in the quad. What's a quad? Anybody?
Something that has to do with 4.
It's... So here's the school, right? Here's the school.
Inside. Like a courtyard.
Here's the quad. Absolutely.
Oh.
It has how many dimensions?
4.
2. It has a length and a width. It's squared. Does this make sense? When we square something, we give it 4 sides or 2 dimensions. So squared quadratics are called quadratics because we're squaring the variable.
Wait, so a quadratic is any variable that is squared.
Yes.
Okay.
Deceptively easy?
Yeah,
Yeah.
I feel like there's a but.
There's always a but. It's always a big one.
You're weird.
Thank you.
Okay. So, does this make sense why they're called quadratics? Because if you have a degree of 4, please don't confuse that with a quadratic. That one is called a quartic.
What?
We will be doing that at some point, but not this chapter. I just
Okay.
want to focus only on quadratics. But quadratic always means squared. So, there will be a lot of times where we're working with really big degrees. And at a certain point, you can do math on them and get them down into a quadratic. Quadratics all have the same characteristics as one another. They all meet certain criteria. They are all easy, fun, yay! Simple, smooth. So if we can get things into quadratic form, that's what we want. Okay. So when you graph a quadratic, what happens? So let's take the function y equals x squared, for example. So
It makes a curve, right?
it makes a curve. So before, we were dealing with linear functions.
So it's a line.
Right. Y, for example, with direct variation, y equals kx. X is only going to increase at a rate of k. That make sense? So the only difference in between how y and x are increasing is this one single number that we keep multiplying by every single time. But when you have something like y equals x squared, y is increasing at a rate of whatever x is at that moment, because we're multiplying it by whatever x is. So its rate of increase is much bigger if x is bigger. Does that make sense? And that's why it creates a curve. Here, it would be like, if we plugged in 2, we'd get 4. 4, like if this were 2. Plug in 4, we get 8. And it just increases at that steady, constant rate. So they have slopes. Quadratics do not have slopes.
Yay.
No.
No,
Slopes.
not yay.
That means
No, I
there's
don't
something
like
else that we.
those slopes. They're so terrible.
But then they have
Now you have to work with curves, though. That's a.
It's okay. When you get into
I think you would
calculus,
be sad.
you're going to be learning about how to find the rate of change of the tangent line to the curve at any given point.
My brother was talking about
Tangent
that.
line would be.
A line that touches at only one point.
He was like, "You think your math sucks?
Oh.
That's gonna suck so much more." And I was like,
No, it won't. It's all relative. By the time you get up there, you'll be capable of doing it. And it'll just be like,
He really is.
wow, I'm actually learning math that people use in the real world. Yay!
So the past like 3 years has been.
A stepping
Been a
stone
lot.
to calculus.
Points.
Okay, so what color do I want to use?
What was that notation you did at like the beginning? I'm trying.
The x to the nth and all that?
Yeah. Where did you find that?
Let me see where it would be in here.
Macro sleeps. Macro sleeps. Did you know that like if you don't sleep for like the recommended amount of time that your body needs, like throughout the day if you're not
It's
doing
going to be on
anything,
page
your body will,
329.
like, doze off. It doesn't shut down. It does like
It's on page 329 at the top, if you want to look at it.
It's kind of like you just
Okay.
kind of like zone out.
It's the standard form for any polynomial.
It's pretty cool.
Okay.
So cool.
Okay. So,
Why does it not happen until
Me.
329?
Shuts down.
because we
I went
only
to bed
focus
at,
on
like-
quadratics before we go into polynomials of higher degrees.
Okay, so
Like,
do I
we
not
just
need
started
that in
with
my notes yet?
No. I mean, I'm just putting it in context for you, so by the time we
Yeah.
get to the polynomials, they make more sense.
Oh,
Okay. So if we have y equals x squared, let's make an xy table. We plug in an x. Let's plug in a 0. What is our y going to be? What's 0 squared?
Zero.
Zero.
Well done. Plug in a 1.
Wow.
What's 1 squared?
One.
1.
1.
Can we just keep it there?
Plug in a 2.
Oh, nice.
What do we get?
4.
4. Now let's get smaller. Let's plug in a negative 1. What do we get?
Negative
One.
one.
What's
No,
negative 1
one.
squared?
1.
Positive one.
Plug in a negative 2. What do we get?
2.
4.
4.
4.
That's okay.
Okay.
4.
So, make our little matches.
That's okay.
And then we just graph it.
Oh, is it like one of the
Just
ones
graph
that
it.
goes like through and then
Yes.
drops
Yes.
down
So
in the
simple.
negative?
Just
Nope.
Just grab it.
Because these are our x's. Okay, so we've got this.
Oh,
point
but
0,
y is
0.
always positive.
Oh,
Okay.
0, 0, 1, 1, 4, 2, 1,
Right.
negative 1,
It's
and
the-
negative 2. You just go, wee!
0, 0.
Like the
We have
bull.
1,
How's it
1.
going again?
But then we also have negative
Just like
1,
that.
1.
Just
Yep.
that simple.
Oh, it's actually.
Wait.
And then we have 2, 4. So 1, 2. So 1, 2, 3, 4. But then we also have -2, 4. So -2, 4. So, because y is changing at a higher rate the larger x is, it creates a curve. Curve. The parabola.
I don't like those.
It sounds like
Yay,
a sort
no
of snake.
slope.
Yeah.
Parabola.
Well, I mean, it's good because we don't have any slopes. But
If you
that's
pronounce
just
it parabola, it sounds like a disease.
No,
I
it's
know.
worse.
So
Yeah, the disease.
we
Well, I thought it
pronounce it
sounded like a
parabola.
Like,
What?
here's the parabola snake, as you can see.
That's what we're like
Very
about
evil.
math.
It sounds
Here's
like
a
Ebola.
parabola, where things follow
looks like a
parabolic paths.
Sorry, what?
Okay.
Wow.
So,
Oh boy.
We're like about
parabolas have certain characteristics that we can study. Even though they curve, so the y does not have a constant rate of change, there are certain things that are constant. Like, for example, the axis of symmetry. What does
Sounds like
symmetry
a no.
mean? Does anybody know?
It means it's symmetrical.
Yes? Very good job, Jacob. What does symmetrical mean?
I can't like tell you the definition.
Equal
It's
on
like
each side.
It means the same coming out from a center point or axis. So,
Yeah.
like a heart is symmetrical. If the heart were the same on both sides, it would look like this. It doesn't.
oh that makes
So there is a center, and it's like you fold it in half on that center line, and everything moving away from the line is doing the same thing on both sides. Which is why a parabola is symmetrical, because there's an axis in the center. Axis as a word just means the point, like the line away from which things rotate or revolve or are measured. That's why your axis in your car, like you've got your tires sit on an axis and they spin. Does this make sense? There's the x-axis, that's where you measure x away from, stuff like that. Okay, so the axis of symmetry is going to have, for every corresponding point, we'll have the same y value for exactly 2 opposite x values.
Is it exactly 2 every time?
There will always be 2 y values, or 1 y value for 2 x values. Yes, for a parabola. Always. So, however far away this is, this point right here, x-wise, from this axis of symmetry, this point will be the same distance. Now, if the axis of symmetry lines up with the x-axis, you can just slap a negative sign in front of that x value, and you'll get the other one. Like here, -2, -2 is +2. Both of those have the same y value. But the axis of symmetry does not have to be right there, so it's important to think of it not as just negating it, but as distance away from the axis of symmetry. Does this make sense? Also makes it easier to graph, because then you only need one side. And then you can just count over, do the other side, and draw your curve.
That doesn't seem so bad.
I don't think it is. I think it's fun. Okay.
But you lied to us.
Did I say
Before.
matrices were fun? I don't think
Yeah.
I did. I don't think I did.
in the
I
very
think at
beginning.
the beginning of chapter 4, when you like open your book, you're like, time for some fun, or like something like that. You were, like,
Well, I
saying
think
fun.
math in general. I like our class. I have fun
Well,
in class.
in the beginning it was easy and fun.
No,
And
That's
then-
hard.
it's.
I don't think
I
matrices
still
were
like
fun
this
at any
class
No,
point.
because
okay,
of
like,
the
but
fun
like-
environment that
No,
it
but
is.
like finding
When
the
it's
determinant
hard.
and doing the
It's-
inverse, that was easy
it's
and
hard.
fun. Like it was just fun to like do it.
Okay.
But then Kramer's rule and all of that was
When
like
Kramer's rule
Well,
rolled around.
At this point,
Like,
like when I do
I
this stuff, it's
finally-
fun.
Mastered, well, not mastered it, but like, I get it. Now I'm like, can we just like stay with matrices the entire
Yeah.
time? Like,
I finally get it.
done.
Unfortunately, we will not see
Like,
them anymore
right
this
when I get
year.
it,
Oh,
it's like,
gosh.
Oh, boy.
Except
Oh,
for on
thank
your
you.
final.
And we will
Okay.
never see it again. Ever.
When you have a parabola, at a certain point, it reaches its minimum or maximum because it turns, right? So, like right here, this one is neither increasing or decreasing if we look at it, what the graph is doing exactly at that point, because that's a turning point. It's like where you turn around when you're on a race. Okay, so this point is called the vertex. So this is the axis of symmetry. And this is the vertex. those are the only two parts of a parabola that we study.
Yay!
Now, graphs in general will have more parts, like x and y intercepts, right? But specific to parabolas, they will have these two things.
You know, it's
Wait, if the do we like read it from left to right? So when the parabola is decreasing is when it's on the left side of the like the axis that
Yes.
it's symmetrical line.
When we're talking about the graph as a whole, and you're referring to it increasing or decreasing, you are always just looking at the y values as the x values increase. So
Okay.
starting over here are very negative x values. So as we move to the right, the x values are increasing, and what are the y values doing? Going down.
Mm-hmm.
Then there's a turning point right here where they're both increasing.
Mm-hmm.
Yes.
Will there ever be any circumstance where we will have to do this on an x, y, z axis? Or is that even a thing? It's not a thing.
That is totally a thing in
Well.
calculus.
Oh boy.
In calculus.
Wow.
You will rotate minifigures about an axis.
Ew.
You will find the volume of shapes. You will find the area under the curve. You can calculate the volume of the Death Star. You could prove the formula for the volume of a sphere. You do all kinds of things in calculus. So much amazingness.
Wait, but if you already have the formula for the volume of the sphere, why do you need to prove it?
Accept everything everybody tells you?
Oh yeah.
No.
Math is all made up.
What's in there?
As long as it still works.
Yeah, what is...
Booze.
I think we should have a chat.
Water.
She's actually gonna smell it.
said that was so...
It looked pretty dark.
No, it's just water.
Are you sure?
You wanna see?
Okay, I
It's
see
because
now.
the cup is full.
She's actually questioning whether or not you're okay.
Yeah, that wasn't necessarily.
You smell it.
I'm really not sure what my
Anything
obligations
besides
are
water.
in that
So
situation.
strong.
Okay, so everybody's got this so far. Parts of a parabola. I'm so glad we're live streaming and recording this for posterity.
Hey, students.
Okay.
Everyone just like
Some of the
wait a
races-
second.
Director's gonna come in and stuff.
I'm right by the mic too.
Well, yeah, and my microphone is at home today, and so the only mic we're using is the computer. So
Yeah.
And that was
today,
pretty loud. So they
your
could hear
voices are all as loud as
Hi,
mine.
everyone else in the other classroom
Hey there,
on the other
friends.
side of the world. I don't know. Where are
What'd you
they?
say?
that. Other
They're
side of the
there.
world.
Oh.
It's probably
They're
fine.
across the
Okay.
far.
Wow.
So,
Far away.
20 minutes.
Well, no, it's like
It's like
no,
an
it's like
hour.
30, 45.
Oh.
Okay,
Yeah.
did
But
I
it's like the other side of
miss
the world.
any parabola constants? Every opposite, like, x value is on an equal y
I
value,
love your logic.
right?
not necessarily opposite.
Fine.
It's two
Right.
x values the same distance away from the axis of symmetry on either side.
You realize I'm just
It's
trying to
only
Okay.
opposite if that axis of symmetry
Just wanna
is the
see
x-axis or y-axis.
Yeah. Okay.
I wanna
But
go
and
back to
then
7th
the
grade.
vertex is the
Eighth
point at
grade
which the
vertex.
parabola is
Two
neither
classes.
decreasing or increasing.
It's turning, right, so it's either a maximum or a minimum.
Okay. Are there any that I missed?
Not yet.
Okay.
We're gonna go in one.
Yeah.
Okay.
Yeah.
Semester got new friends this year.
But when's this just
Yeah. And then I made new
not-
friends.
So, this is
Yeah.
super
Maybe we'll
mucho
show.
supremo important.
I have finance.
Oh.
Is the standard form for a
But those are
quadratic
okay.
equation. Write this down.
I got so used to using this, like 2 years ago.
Good.
Every day,
Why?
all the time, this formula was a part of my life.
So can you solve it for x?
Go for
Not
it.
right now. I'm completely. This was 2 years ago, before I did geometry.
Okay.
Wait, so
Oh yeah,
this is
geometry
your
just strips you of
algebra
everything else you knew
one?
before.
Because
Yes.
I don't remember any of this. You know, I took a really...
I just remember this
Curriculum?
formula being my
Yeah.
life for like a semester.
Yeah.
all the
In
way.
what?
My mom literally just like
Algebra?
skipped a lot of algebra
One?
one because I
I
didn't
don't
do too
remember
well
this.
on it, so she just skipped it.
Algebra
Not the
1
best
did
decision
you
on her
do?
part, but I don't
Algebra
blame
1
her.
was easy.
I
It
was
was just
dumb.
like
Okay.
super
Something
simple
else to
math.
note. The reason this is called standard form is because this is the form that all polynomials will default to. This is how we write polynomials so that we make sure that we're all writing them the same way. We want to build on the mathematical work of someone somewhere else in the world. We don't have to speak the same language. We don't have to worry about trying to find the way that they've written things down because they'll always write them in standard form. so that we can compare, so that we can interpret, so we can understand.
Okay,
So-
wait, so this is standard form of a polynomial?
That's of a quadratic, but I'm showing you now another
Okay.
polynomial
Oh.
to show you the example.
Oh.
That's standard form.
And then ax to the 4th.
Yes.
Ooh. This is. So you can go all the way down the alphabet and start with 25.
Yeah, but then at some point you gotta start coming up with new
We don't really
variables
use
once you
E.
get through.
We don't really use
Well, there's
E
an
because
answer.
E is a number.
It is.
Oh, yeah, it's that thing that I don't know what it is.
It's like
yet.
10 to the something.
It's 2.12718 or something.
Oh,
Ugh.
really? Okay, so 24.
There you go.
Hey,
So
it's
these
gonna
are the
go
standard
down.
forms for cubic and a quartic, and it would go on and on and on and on and on.
Are we gonna use this? Like, should we write this down?
You should recognize what standard form is and not think about it as only applying to quadratics, so that when we refer to the standard form of any polynomial, you understand that that means you putting your variables in alphabetical order with decreasing order of degree. So that here, x, the degree of this term is 4, the degree of this term is 3. It's counting down until we get to the point where the degree is 0, because what's x to the 0? Does anybody remember that?
X to the 0.
Is 1.
What? Oh, ew.
So
That's such a
1
weird
times
noise.
f.
Ew. I don't like it.
I don't
Wait.
remember this.
F times x to the 0 is 1.
No, it's f.
Is f.
Right. Because
But
x to
then
the 0
x to
is
the 0
1.
is
Oh, I see what you
Okay, so now we're going to start talking about the characteristics of quadratics.
mean. They're so messy.
No, minor
No, mine are
So-
messier.
When you're looking
minor.
when you're looking at a standard form of a quadratic, these 3 numbers are the only ones that change from one to the other, right?
Mhm.
Because x squared is still going to be x squared, and x is still x. So a, b, and c are what make each individual quadratic equation unique. Does that make sense? Those are the only ones changing. So we're really interested in those numbers. They tell us a lot about what this particular quadratic function is doing. What is special about this one? How wide is it? Where does it open? Does it open up or down? Is it shifted away from the axes? What's it doing? These are the numbers that dictate that. Does that make sense? So, when we are looking for our axis of symmetry is always going to be a vertical line. Does anybody remember what the equation for a vertical line is like?
Has an X in it.
It has an x in it.
Oh!
Oh wait, the slope is
Undefined,
Yeah, that one.
right? Because there's no change in x. X is a constant.
okay.
To find the axis of symmetry for any quadratic formula or equation, it's negative b over 2a.
Wait, what is
I
that?
can't believe I remember.
Negative b, 2a is the axis of symmetry.
Okay.
This stuff is supremely important for this chapter. Now, if we were to, remember that equations tell us how x and y's compare to each other at any given point. So every y is exactly, take the x there, square it, multiply times a, multiply times b, add them together, and then increase it by c, and that's what will give you your y value there. Does that make sense? Okay. So if we were to use this as our x value, that's going to give us the y value at the axis of symmetry. So that gives us the vertex. Does that make sense? Because the vertex, you can see, is the point where the axis of symmetry crosses the parabola. Because it's the middle. So, that x value right there is negative b over 2a. And the y value is f of that. F being function notation. Do that math on that x value. So, a vertex is a point, and it's the point negative b over 2a, and then f of negative b over 2a. Write that down.
Oh. Wait, F is meaning...
Function notation, meaning do that math, this, on that x.
Okay, so...
This is f of x equals. F of x equals y. Because that's what y is what we get when we do all this math on that x. It simplifies into the y. So f stands for a times argument, whatever we're doing it on, squared, plus b times whatever we're doing it. Does that make sense?
Okay. Yeah.
Okay.
That's really hard to remember for some reason.
It's just weird.
The other thing that we can tell, or two more things we can tell immediately by looking at the standard form of any quadratic equation. What would we get if we plugged in 0 for x?
0.
We'd get 0 here, and we'd get 0 here. What about here?
C.
C. So the y-intercept is always 0c. Because if you plug in 0 every single time, all the x's will go away, and all we will be left with is c.
A lot of terms.
The other thing that we can tell, now say we plug in an x value, right? Any x value, doesn't matter what it is. So we plug in 1, let's make it easy. 1 squared is 1, but then we need to multiply it by a, right? So however fast the y's are increasing, is increasing at a rate of x times x, but also times a. A tells you how steep or narrow or wide a parabola is. So if a is bigger than 1, it's a narrow parabola. And if a is in between 0 and 1, meaning it's a fraction, it's a wide parabola. Now what if a is negative? We plug in positive x's, and what happens? We get the exact same x or y that we would have, except now we need to make it negative. What does it do when we make a y negative? It flips it down here. So having a negative a is reflected across the x.
Wait, having negative a in standard form?
Yes.
Okay.
Now here, when we have our parabola facing up, very nice and pretty, our parent function, meaning it's not altered by any other math other than just squaring the x. This right here, this vertex, is the minimum. If a parabola opens up, your vertex is a minimum. I'm saying this emphatically because that's important. Now, if your parabola opens down, that vertex, that turning point, becomes a maximum. And that's
if
it.
it opens up,
Homework.
it doesn't have a maximum, right?
Right.
Sorry. Okay.
What if it's...
That's not just it. You didn't do homework. I'm going to do examples and stuff.
Okay.
So, but yes, absolutely. It won't have a maximum if it opens up because there is no limit to how high it will go
It's just going to keep going.
forever. And so there will never be a point that's higher than the others because we can always keep going.
Yeah.
What if it's sideways?
Then it's not a function.
Because
'Cause
you
if
can
it's
put a vertical line
sideways-
through it.
Still valid math. That's totally a relation. We will do those this year. But it's not a function, so it wouldn't be in this family of functions. It's still a quadratic, but it's not a function.
What is the homework?
Oh, the homework is also on the Google thingy. It's like 17 through 53 odd or something.
Okay, so I'll just...
Okay. And that wasn't it. We need to go over one more form. I don't think you guys need to... Hang on, let me think.
Okay. If I use the restroom now, will I miss anything important?
Yeah.
Okay.
Guess you're not going to the bathroom for a while.
We'll just do one more form.
Okay. So, does anybody still need any of this? Because I'm about to erase it.
Nope.
Okay.
So it's 5.1.
What page are we looking at now?
250.
Oh no.
Okay. I liked the way that worked. Oh no. Okay.
I'm
So
like feeling it.
when we have our parabola that looks like this and it's just centered right there, that's called our parent function, right? And our x and our y intercepts are the same. They're both the origin. Simple. But what if they're not? What if x is like slid over a little bit? Well, then that would become y equals, like say this is y equals x squared, okay? Then if we're moving that x, we slide it over h. Now this is also important. Because x is the independent variable in functions, if I want to move x over here, I need to make sure, how is it going to affect my y? Well, let me think about it. If I have y equals x squared, right? And then I've got my xy table. I plug in a 1, and I get a 1. I plug in a 0, and I get a 0. If I have y equals x minus 1 squared, now what do I need to plug in to get 0? If I want my y to be 0, 0 equals x minus 1 squared. What does x have to
1.
be? But a positive 1, even though it's x minus 1.
It's squared.
It is squared, but it's because we're thinking about how do I like move backwards? How do I get that 0? If I'm subtracting 1 from x, then to get the same value as before, my x needs to be bigger to get the same value. Does that make sense?
Yep.
So, a negative h means shift the whole thing to the right.
Is this in Vertex Form?
This is, yes. A positive h, when we're looking at the formula itself, means shift it to the left. So the whole graph will just get picked up and moved to the negative side. Or just not necessarily on the other side of the x-axis, but in the negative direction. Or y-axis, I meant. Does that make sense? Now the reason I'm using h is because we talk about the vertex as the coordinates hk. H is the x, k is the y. So that also means my axis of symmetry is x equals h, because that's the x coordinate of the vertex. That's where the axis of symmetry is going to pass through on the parabola. Does that make sense? Packing in a lot of information, so I want to make sure you guys get it before I build on more. Okay. So k is describes my range, right? Because the y values are what range is. Range cannot be, like, for example here, my y cannot go beneath this k. It just doesn't. It's bounded. That's where it turns. So k describes my range. If the graph opens up, then my range is everything bigger than k. If my graph opens down, my range is everything less than k, including k, of course. Does that make sense? So, if I move this k, I'm not moving the x values, so I'm not going to move anything inside here. I'm going to move the y values. So I'm just going to keep adding this k on the outside after I've done the math on the x, because it's not the x values that are changing with k, it's the y's. Does that make sense? Okay. The only thing we're missing then is that first coefficient that determines how wide or how narrow it is and if it opens up or down. And that's a. So, I'm just going to put this out front. Because order of operations, I still need to square this first before I distribute in my a, so it will still give me ax squared plus blah, 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 blah. Make sense? This is called vertex form. And Vertex Form is your friend. It will come to your birthday parties. It will text you when your boyfriend breaks up with you, make you feel better. It will bring you cookies when you're feeling blue. It'll be there to support you. It won't do any of those things. It's inanimate. It's just a concept.
Dang it.
Yeah.
Really hoping for a new friend.
Smoke B in Counter-Strike.
Okay, the reason it's called Vertex Form is because you can see the vertex right there. So if you are given an equation that looks like this, what's the vertex?
4, 2.
Yes! Yeah. Nice job, Tori! What's the axis of symmetry?
Is
4.
X equals 4.
oh right,
Absolutely.
because it's that way. Yeah. Sorry.
Is this positive or negative?
Positive.
Right. So is my graph going to open up or down?
Up.
Up. Yes. So my range, is my vertex then a minimum or a maximum?
Wait, the what?
The vertex, the turning point of the graph. Is it the
Minimum.
lowest point? Yes. My vertex is a minimum, which means my range is y is greater than or equal to 2. Because it opens up. See all that information that we got just out of this? And because this is bigger than 1, we know it's going to make it steeper. Cool.
What is X? 4?
What is 4?
Yeah.
It's the axis of symmetry. So it's the vertical line that cuts the graph in half and passes through the vertex.
Wait. Never mind.
Okay.
I got it.
You guys just learned so much. So proud of you. Okay. So,
This is all in the book, right?
yes. Okay.
I'm guessing that we won't get it just by reading it. Or at least I will.
I just had a conversation with a parent about that. Not one of your parents. Different one.
Was it a grumpy parent?
No, she was thinking about adding her daughter to my calculus class, but she lives in Oceanside, like inland, and it's going to be too far. But she was talking about how her daughter's been trying to teach herself calculus, and I was like, well, bless these textbook authors' hearts for giving it a good go, but they just don't speak teenager. It's really hard for teenagers to read this stuff and then just get it. And that's fair. It's totally legitimate. Okay. So, if we're going to be looking at, what's the notation they use there? P. If we're going to be looking at where the graph actually touches the x-axis or crosses, what is the y value along the x-axis? Any point on the x-axis has a y value of? How up or down is a point that's on the x-axis?
0.
Right. The y value on the x-axis is always 0. Okay? So, if I want this to be 0, what does x need to be equal to? If x minus p equals 0, x equals
P.
p. And if x minus q equals 0, x equals
Q.
Exactly. So p and q are my intercepts. That's what will make y equal to 0.
Wait, which intercepts are they specifically?
X.
Both? What? Wait, P and Q are both an x-intercept?
Yeah, because it's curved.
Oh, right, so it can have 2 points of intercept. Gotcha.
Those are my x-intercepts. And remember, my y-intercept is just the c value when I expand this all out. Good?
Yeah.
So, does everybody remember how to FOIL?
Mm.
Okay. Review!
Wait, foiling is just
I looked it up.
distribution, right?
Exactly. If y equals x minus 4 times x plus 2, FOIL stands for first, outer, inner, and last. Because it looks like this. You do your first terms multiplied together. Then you do your outer terms multiplied together. Then you do your inner terms multiplied together. And then the last combination you haven't yet done.
Oh, okay.
So essentially what you're doing is taking this x and multiplying it times each one of these. And then you're taking this -4 and multiplying it times each one of these. And then you'll just collect like terms. So, foiling this particular problem gives us y equals, my first terms multiplied together, x times x, x squared. And then x times positive 2 plus 2x. Now I'm moving on to my -4. -4 times x is minus 4x. And -4 times 2 is -8. Here are my like terms. So y equals x squared minus 2x minus 8. So if you get a problem that looks like this, and they ask you, convert it to standard form, just FOIL it out.
Oh,
Not standard.
And that would be the answer. This is standard form. Y equals ax squared plus bx plus c. Where a is
So-
1, b is -2, and c is -8. Okay. So, what if they give it to you in vertex form, and they ask you to convert it? I'll use this one. So what if they say y equals 3 x minus 4 squared, it's just using the same one as before, plus 2. And they want you to write this one in standard form. Well, you need to obviously get rid of these parentheses and stuff, because those aren't in standard form. So let's follow the order of operations. First thing I need to do is square it. So that's y equals 3 times x minus 4 times x minus 4 plus 2. Because exponents mean I have that many of whatever it's touching multiplied together. So I have 2 x minus 4s multiplied together. So then I FOIL from here. Y equals 3 times my x times my x squared, x times -4 minus 4x, -4 times x minus 4x, -4 times -4 plus 16 plus 2.
Do you have to do that, or can you just multiply 3 by all of them?
You could multiply,
and
you would only
that's
multiply
standard
3
form?
times one of them at a time. Because
Yeah,
if you
like-
multiply 3 times all of it, that would be multiplying 3 times this and then 3 times this, which is actually multiplying times 9. Because you've multiplied times 3 twice, and you only needed to multiply by it once.
wait.
So as long as you multiply by each.
I don't recommend that you distribute the 3 first.
Okay.
Especially because this is always going to FOIL out to be a pattern
Okay.
of y equals 3 times the first term squared. Our first term was x squared.
Well, and that's part of PEMDAS too, right?
Yeah.
To do the squares.
Oh, and it just works out all nice and pretty.
And then minus 8x.
I get it.
So it's this times this doubled. And then plus the square of the last term. Plus 2. And that pattern is true for every single binomial, which means 2 terms in a polynomial square. So that's going to give me, distributing my 3 now, 3x squared minus 24x plus 48 plus 2, combining my like terms, y equals 3x squared minus 24x plus 50.
Ah,
Where my a is 3, my b is -24, and my c is 50. So as another quick review of what we just learned today, my y-intercept is 0, 50. This is positive, so it opens up. And my axis of symmetry, which is -b over 2a, is -24, which makes it positive. over 2 times 3, which is 6, which is 4, which we knew because our axis of symmetry is also x equals h, and that's h. Make sense?
How do you find the axis of symmetry again?
Negative b over 2a. B was negative 24, a was 3. Just plug that in and simplify.
And so for the y-intercept, it's just 0 and then 50.
Yeah,
Last
0c. Right.
Okay.
All right. Basic.
Yeah.
Okay.
I was just about to do one more thing.
Oh, are we reviewing still?
No, I was going to teach you one more thing of how to graph.
I mean, okay, yeah.
We should structure our classes so we have like a break period at some time.
There's a
Okay.
10-minute bathroom break.
No, 3 minutes.
Oh.
Does anybody need this? Everybody's got it? Okay. Did it kill Samantha?
Yes.
Was that bad?
She's taking a microsleep. That's not really
She's-
I didn't pick
that's
up
a real
any
sleep.
of that stuff earlier. I'm so out of focus right now. I felt like I'm talking to a camera.
It's like a computer
Okay,
crash.
so
She just
now-
went into a coma.
We are going to graph equations
I'm
based
close to
on whatever their equations are.
What? It's too early.
It's not early at all.
Oh.
It's almost noon. 11:20 something. You okay?
I got up to
Okay. So we are going to graph. Let's see. Where's my green one?
The time change was so nice.
Oh yeah.
Y equals negative x plus 2 times x minus 4. Oh, that's the same one I've just made up. That's weird. This is example 3. That's weird. I just had that same one.
Maybe part of your mind is like, we'll just do the exact same one. Just to
So,
make it simpler.
my intercepts, remember, x minus p. So my intercept is minus x minus what? Negative 2. Because minus and negative simplifies to a positive, which is how we're given it.
Wait, don't you want to do FOIL first?
No, I'm graphing from here.
Oh.
So, I've got negative 2 right here. And then x minus 4. So then it's going to be 4. Because the equation is x minus q, where my intercept is q0, 4, 0. And it opens down. Right? So, 1, 2, 3, 4, 5, 6. There are 6 slots or whatever, spaces, distance in between these two. The axis of symmetry is going to be dead in the middle. So I know my x value is going to be 3 away from each one of them, right? It's going to be 1. If I plug in 1 right here, y equals negative 1 plus 2 times 1 minus 4, which equals negative 3 times negative 3, which equals, this was negative 9, positive 9. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. My vertex is the point 1, 9. Because I knew it was going to be 1, because that's where my axis of symmetry is, because that's what's in the middle. And 9 is what I got when I plugged that in. So, and I know it faces down, because my A is negative. There it is.
That's it?
That's it. That's how to graph it.
Where did that form come from? The y equals a times x minus b times x minus q.
That's intercept form.
That's intercept.
It is?
Mm-hmm.
Oh, okay.
Okay, now, what if they give it to us in vertex form? Like y equals 1/2 x plus 3 squared plus 4. Well, my vertex is what? It's HK. So
3, 4.
Close.
H.
X minus H.
Oh.
Negative 3 and 4.
Negative 3 and 4. So my vertex is 1, 2, 3, 1, 2, 3, 4. Will it open up or down?
Up.
Why?
Positive A.
Yes, because A is 1/2. It's positive. So at this point, I can just, how do they do it? Do they plug it in? They don't tell you how. Okay, so at this point I can see it's going to be negative 3. So I can plug in negative 2 and negative 4 and simplify that. So y equals, if I plug in negative 2 plus 3 squared plus 4, y equals negative 2 plus 3 is 1, right? 1 squared, 1 times 1/2 is 1/2, plus 4 is 3.5. We're at 4.5. So, at negative 4, or negative 2, right? 1, 2, negative 2, 4.5. Then if I plug in negative 4, I will also get 4.5. And how do I know that? Because I will always get the same y value, the same distance away from the x-axis, or the axis of symmetry. Does that make sense? Okay. So then I have enough points. Woohoo! There's my parabola. That's it.
Oh, that's all?
That's it. That's all of it.
I was being sarcastic. That's a lot.
That's a lot. Take it slow. Okay.
It's really hard not to get overwhelmed just looking at it.
Okay.
You
Don't
can
do
do
it.
the past like 30 seconds.
And I've
Okay.
got so much stuff to do when I get home. Okay, now you can go
That's
to the
it.
bathroom.
Thanks.
Have fun.
Now you can go to the bathroom.